yesterday by sort of making this connection between the numbers that appear in Pascal's triangle and the coefficients of the various terms in the expansion of a binomial raised to an exponent. Something like this, x plus y to the power n. So here are a few lines of the expansions with various different exponents. And another thing that we saw towards the end of class is that all of the numbers that appear in Pascal's triangle happen to be various combinations. Okay? And so if we look at, for example, this would be the sixth row of Pascal's triangle, and then this is the fifth row of Pascal's triangle, and then the fifth row of this expansion, x plus y to the n, we can see that these coefficients that are in Pascal's triangle align with, or sorry, it would be this one actually, I was right, the fourth row, with the both the terms in Pascal's triangle and with these combinations. Okay? And so if we kind of look at taking this expansion, and I believe we did this one yesterday just by hand too, or maybe we did up to the cubed piece. This number 1, oh, I hope it lets me write. Oh, I can write in black again. Yesterday I could only write in red. This term over here, 1 times x to the 4, if you want to think it more in terms of it more generally, we can think of this as 4 choose 0 times x to the 4 minus 0 times y to the 0. Okay, that is this term. Okay, so the coefficient is 1, and that is 4 choose 0 is 1. Now the reason why I know x to the 4, like you would never write it as x to the 4 minus 0 times y to the 0, but there is sort of a method to my madness. What we are going to see is that there's going to be a trend around these two numbers. And in fact, if you look ahead at all of the various exponents, what you can see is that they always sum to 4. Okay, so this next term here is 4 choose 1 times x to the 4 minus 1 times y to the 1. Okay, 4 choose 1 is 4. This next term here is 4 choose 2. 4 choose 2 is 6 times x to the 4 minus 2 times times y squared. Okay, so what's happening is the coefficients are various combinations, and we start with the highest power of the first term in that binomial, and then as we go along term by term, the exponent on the first term decreases by 1, and the exponent on the second one, which is y, increases by 1. Okay? This guy over here is 4 choose 3, x to the 4 minus 3 times y cubed. Okay? And then the final one, this guy, is 4 choose 4. 4 choose 4 is 1. X to the 4 minus 4, which is 4 to the 0, y to the 4. Okay? And so if you think about all of these various exponents, 4 minus 0 plus 0 is equal to 4. 4 minus 1 plus 1 is equal to 4. By writing it out this way, we ensure that the sum of those exponents is always equal to whatever this guy is over here. Okay? And the reason, again, that we want to do this and kind of make it look even more complicated than it does in the first place is that ultimately we want to be able to use this so that we can start, let's say, from the 7th expansion of a binomial, rather than having to start at the top in Pascal's triangle and work our way down. we can just start with whatever particular line we want. Okay? And in general, if you're looking at the expansion x plus y to the n, okay, then the term, actually let's just go back here. What I'm going to do is call this guy term 1. This is term 2, term 3, term 4, and term 5. Okay, so one thing that we should notice is that there's always one more term than whatever's on the exponent. Okay, so when you have x plus y to the 0, you have one term. When you have x plus y to the 1, you end up with 2 terms in the expansion. X plus y squared, you have 3 terms, et cetera, et cetera, et cetera. Okay? So if we want a specific term, and there's a reason why I'm writing it that as tk plus 1, which you'll see in a second, we can figure that out by doing n choose k times x to the n minus k times y to the k. Okay, now as an example, the second term in x plus y to the 4. And I'm picking this one because we've just looked at what that is on the previous page. Okay, now the second term, if we go back for a second, this second term, do you see how the number that we have to choose is 1 less than the term number? Right? So for the first term, this number is a 0. For the second term, this number is 1. For the third term, this number is 2, et cetera, et cetera, et cetera. That's why we have in the general formula, this guy's k plus 1, this one is k. Because the term number is always 1 greater than whatever we're choosing. Okay? Now if we are choosing the second, if we want to know the second term, t2, then k actually has to equal 1. Because k, the term number over here is k plus 1. So if this is 2, this would have to be a 1. Right? If we're looking at t2, then k is actually equal to 1. Okay? This will be n. Now n in this case is 4, because n is the exponent on the entire thing. 4 choose 1 times x to the 4 minus 1 times y to the 1. Now, 4 choose 1 is 4. X to the 4 minus 1 is x cubed. Y to the 1 is y. And so we have a way actually of getting whatever term we want in a specific binomial expansion. Okay, now we're going to do a lot of practice on this. But as I said, like, this is quite handy because it means that we don't have to start from scratch in terms of doing binomial expansions, right? We don't have to start, let's say we're doing, I don't know, a plus b to the power 8. We don't have to start by multiplying 2 of them out and then adding in a third and a fourth, all until we get all the way to all 8 binomials, right? We can just figure out all of the terms if we want, or figure out whatever term we want in that particular expansion. Okay, so just as an example, this is supposed to be c plus d to the 5. Okay, so here n is equal to 5. So if we wanted to know the coefficients in the expansion of this, the first one would be 5 choose 0, and then 5 choose 1, and then 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. Those would be the coefficients in that expansion, right? There would be 6 terms in the expansion because there's always one more term than the exponent on the binomial. And the coefficients are various combination values. So 5 choose 0 is 1. 5 choose 1 is 5. 5 choose 2 is 10. This is also 10. This is 5, and this is 1. Okay. Now, if you wanted to add in, well, actually, let's just do that. We'll do this step by step. Okay. How many terms are there in the expansion of c plus d to the 5? Okay. There are 6 terms. There's always one more term than n, which is the exponent. Okay? And then determine the simplified expression for the 4th term in the expansion of, again, c plus d to the 5. So when you're asked this is a very common type of question. Figure out this term in the expansion of this binomial. Okay? What I like to do is start with this. We're looking for T4. Okay? Now, the formula to find a specific term is tk plus 1 equals n choose k times x to the n minus k, y to the k. Okay, so we're looking for T4 here. Now, to put things into this formula, we need to know a few things. So firstly, we need to know what n is. And n is always the exponent on the binomial. So in this case, n would be 5, because we're going c plus d to the 5. Okay? Now, x and y in this case are just c and d. Just replace those variables with c and d. What would k be if we're looking for T4? Yeah, k is 3 because k plus 1 has to equal 4. Exactly. So that's the place where people sometimes make errors because the k value is 1 less than the term number. Okay, so T4 is going to be n choose k. So 5 choose 3 times x to the n minus k, so c to the 5 minus 3, and then y to the k, d cubed. Okay, and then piece by piece, we can look at each part of this term. So 5 choose 3 is 10. This is c squared, and this is d cubed. And that's the 4th term in this expansion. Okay? All right. So let's take another example. Expand the following. 3x plus 2 to the power 4. Now, here's where things get a little bit, where you're going to see some differences from those values that show up in Pascal's triangle. Because what's happening here is that we don't just have x plus y or a plus b or c plus d, but our sort of quote-unquote x and y values have numbers in them as well. So those will also get raised to various exponents. Okay? So let's just do this sort of piece by piece. So firstly, n, in this case, is 4. Our x value is 3x. I'm going to put that in quotes because x is not equal to 3x. But in terms of, we've got tk plus 1 equals n choose k, x to the n minus k, y to the k. So the thing that's sort of in that position is 3x, and the y in this case is 2. Okay. Now, if we want to know the entire binomial expansion, if we wanted to expand the entire thing, how many terms would we see? N is 4. 5, yeah. And in fact, if you think about T1, k would be 0, because it's 0 plus 1. So this is essentially going to be, start with 4 choose 0 times, in this case, it'll be 3x to the 4 minus 0 times 2 to the 0. That's the first term. And in fact, maybe what we should, I'm actually going to erase this because I know I need to write a little smaller. I'm going to run out of space. But think about it this way. It's going to be T1 plus T2 plus T4 plus, nope, T3 plus T4 plus T5. It's going to be 5 terms in this expansion. Okay? For the first term, k is 0. So this first term is 4 choose 0 times 3x to the 4 minus 0 times 2 to the 0. The second term is, if the term number is 2, k is 1. So 4 choose 1 times 3x to the 4 minus 1 times 2 to the 1. In the third term, k would have to be 2, because k plus 1 is 3, so k is 2. So this is 4 choose 2 times 3x to the 4 minus 2 times 2 squared. Right, and this one is 4 choose 3 times 3x to the 4 minus 3 times 2 cubed. And then finally, 4 choose 4 times 3x to the 4 minus 4 times 2 to the 4. Okay? So this is kind of like the hardest part, just laying that out for yourself. Laying all the terms and how to calculate each term is the hardest part. Now we just have to look at each individual term and sort of simplify it, right? So for example, in the first term, 4 choose 0 is 1. 3x to the 4 minus 0, that's 3x to the 4. That's 81x to the 4. And 2 to the 0 is 1. For term 2, 4 choose 1 is 4. 3x to the 4 minus 1 is 3x cubed. So that's 27x cubed. And then this is just times 2. 2 to the 1 is 2. Okay. 4 choose 2 is 6. Wait. Yes, 6. And again, look, I'm doing this in my head, but you can do it on a calculator, right? You can do the 4 choose 2 part on your calculator. You don't have to memorize those. You don't have to do them in your head. This will be 3x squared, so that works out to be 9x squared altogether. And then 2 squared is 4. Okay, this one will be 4 choose 3 is 4. 3x to the 4 minus 3 is just 3x to the 1, or 3x. 2 cubed is 8. And then 4 choose 4 is 1, times 3x to the 0 is 1, times 2 to the 4 is 60. Okay, and so now completely simplified, this is 81x to the 4. This guy is, let's see, 104, 216. 216x cubed plus, I don't know what that is. Can't do it in my head. 36 times 4. No, sorry. It's the same, isn't it? Is it? No. Yeah, it is. It's also 216, isn't it? Yeah. This is also 216x squared. This guy would be 12 times 8 is 96. 96x. And then plus 16. And that is the full expansion. Okay. So when you practice these a little bit, they're really not terribly difficult. What I would recommend, though, is do not skip lines in this, because that's where people make mistakes, right? If you do too much in your head, then if you try and go, let's say, directly from this line to this line, you're very likely to make a mistake, or more likely to make a mistake than if you put the middle line in first. Okay? So that's where we have to expand the whole thing. Here's another one. So again, it's to the power 4. Okay, so our n value is 4. Okay, the sort of x part is 2x, and the y is negative 3y. So make sure that you keep whatever sign goes with each term in the binomial. That has to be part of this piece as well. Okay. So again, because it's our n value is 4, we're going to have 5 terms. So I like to, again, just want t1 plus t2 plus t3 plus t4 plus t5. Okay? And then you may also want to have this handy. This is on your formula sheet, by the way. Okay. And the other thing is that after you practice this a little bit, you may not need to write every little piece of this out. So for example, a place where I might skip is I don't need to write 4 minus 0 there. I know it's going to be 4. And the next one's going to be 3, and the next one's going to be 2, and the next one's going to be 1, and then 0. And going the other way, it's going to go 0, 1, 2, 3, 4 for the second term, right? So you could do something like that, where this first term is 4 choose 0 times 2x to the 4 times negative 3y to the 0. Okay. The second one will be 4 choose 1 times 2x cubed times negative 3y to the 1. The third one will be 4 choose 2 times 2x squared times negative 3y squared. 4 choose 3 times 2x to the 1 times negative 3y cubed. And then finally, 4 choose 4 times 2x to the 0 times negative 3y to the 4. Okay, and so now I'm just going to simplify each term. So this one is 1 times 16x to the 4 times 1. Second one is 4 times 8x cubed times negative 3y. The third term would be 6 times 4x squared times 9y squared. Because if for the second piece, if the exponent on that negative 3y is even, it will become positive. Okay. This guy will be 4 times 2x times negative 27y cubed. And then finally, 1 times 81y to the 4. Okay, and then when we put that all together, this is 16x to the 4, and then this will be negative minus 96x cubed y, and then positive plus 216x squared y squared, negative minus 216x squared y, xy cubed. And then plus 81 y to the 4. Okay. So this is a more common type of question where you're just looking for one term. Find the 8th term in the expansion of 3x minus 2 to the 11. You just want the 8th term. Okay. So when you are asked for just one term, this piece becomes really important because if you can just identify these 4 things, you can just plunk everything into the formula. Okay. So first, if we're looking at 3x minus 2 to the 11, what's our n value? 11. Okay. What's the x piece? 3x. And then y? Negative 2. Okay. Now we're looking for the 8th term. So what's k? K is 7. That's right. Right? K is 7 because k plus 1 has to equal 8. Okay. So here if we are looking for t7 plus 1, you could put t8 there if you want, but sometimes if you put 7 plus 1, you remember, okay, k is actually 7, not 8, is equal to 11 choose 7 times 3x to the 11 minus 7. So that will be to the 4 times y, negative 2, to the k, 7. Okay. Now I'm not going to attempt to do the 11 choose 7 in my head. So let's do that on a calculator. Okay, I'm getting 330 for 11 choose 7. And then 3x all to the power 4 is 81x to the 4. And negative 2 to the 7 is negative 128. Okay, so to get the entire term,
I have a facility operator call the office at 2322. Facilities call the main office at 2322. Thank you.
I need to multiply all the numerical pieces together. And I'm getting negative 3,421,440 x to the 4. Okay. So far, so good? Yep. Okay. So let's make this a little bit more challenging. Okay. Find the middle term of a squared minus 3b cubed to the 8. Okay, middle term. Which one's the middle term? So let me ask you something. How many terms are in this expansion? 9. Yeah. 9 terms in the expansion. Okay, so which one would be in the middle? The fifth term. Yeah. T5 is in the middle. Okay, so once you can pick that piece apart, this becomes a lot easier. Okay, so n is 8, x is a squared, y is negative 3b cubed, and k, if we're looking for T5, what's the k value? 4, right. And again, that's because k plus 1 has to equal 5. Okay, so T5, or T4 plus 1, is 8 choose 4 times a squared to the 4, or to the 8 minus 4. So, you know, it might be a little bit deceiving. This should actually be this number minus this number, but it happens to be the same thing because it's right in the middle. And then times negative 3b cubed to the 4. Okay, and 8 choose 4 is 70. Okay, this is going to be 8 to the 8. And this one will be 81b to the 12. Is that right? Yeah. Okay, so all together. Sorry, positive.
Oh,
You know what? I think I said negative, but I wrote positive. Positive 81. Yeah, thanks. Because this exponent over here is even. Yeah. Okay, so 70 times 81 is 5,670. A to the 8, b to the 12. Okay. So far, so good? All right, let's keep going. Okay, so find the constant term independent of x in the expansion 2x minus 1 over x squared to the 18. Okay. So this one is going to be a little tricky. Constant means there's no x in there. So whatever the x in the numerators would be, that whatever the exponent in the numerator would be would have to cancel with the exponent in the denominator. Okay? We have to figure out what term number that's going to happen. Okay? If you think about it this way. For the first term, the exponent on here would be 18, and the exponent on here would be 0. So we're going to have an x to the 18 in the first term. Does that make sense? In the second term, this will be x to the 17, but this will be over x squared. So the exponent on x overall will just be x to the 15. Because some in the numerator cancel with some in the denominator, but they also cancel at a different rate. It's not like one's going up at the same rate that one's going down, because there's more x's in the denominator than there are in the numerator. Okay? Now, when I'm working with this type of problem, because it's pretty common, you may get a problem like this where it says, what's the constant term? Or you may get a question, and actually we're going to do this in a minute, which is like, what's the term that has an x to the 14 in it or something? You have to find that specific term number. Okay? What I do for these ones is I don't pay attention to any of the coefficients when I'm figuring out the term number. I just pay attention to this and this. In every single term, we're going to have powers of x, and we're going to have powers of 1 over x squared multiplied together. We want to know essentially when that exponent is going to be x to the 0, because if it's x to the 0, that means we get a constant term. Okay? So what I do is I just sort of pay attention to this part and don't worry about the numerical coefficients. Every term is going to have an x to the n minus k in it and a 1 over x squared to the k in it. Now, of course, there's actually going to be a 2 in there and a negative 1 in there. But again, we just want the term number right now. We don't really care about the number part. We'll work that out after. Okay? We need to know when this is equal to x to the 0. Because if it's equal to x to the 0, then we have a constant. The number of x's in the numerator will cancel with the number of x's in the denominator. Okay? So at this stage, what I would do is like think about distributing this in. We're going to get x to the n minus k times 1 over x to the 2k, right? Because that gets distributed in, equals x to the 0. And if you kind of put this together into a single expression, we'll have x to the n minus k over x to the 2k equals x to the 0. Okay, this is actually an exponential equation. And so if we can write the left side as a single power, then we can drop the bases, set the exponents equal to one another, and solve for k. Okay, so to simplify this, this is just the quotient law. When you're dividing two powers with the same base, we can just subtract their exponents. So this will be x to the n minus k minus 2k equals x to the 0. You know what? I just realized we know what n is, don't we? Yes. I should have done that from the beginning. N is 18. So let's put that in now. 18 minus, this is going to be 3k equals x to the 0. And now we can say, okay, well, 18 minus 3k has to equal 0. Okay, and so that means 18 equals 3k, which means k equals 6. So if we're looking for when k equals 6, in fact, we're looking at the 7th term. Okay, so here, k equals 6. That's really the hardest part, is figuring out the term number, right? N is 18. X is 2x. Y is negative 1 over x. Sorry, negative 1 over x squared. And now we can just kind of plunk everything in. So T7 in this case will be 18 choose 6 times 2x to the 18 minus 6 times negative 1 over x squared, the 6. Yes?
I could just be blind, but does it matter that you left the negative out of, like,
This part?
equation? Yeah.
No, so I purposely avoid, what I did really was, all I wanted to know is when the piece with x in it has an exponent of 0. So I ignored all of the coefficients that go along with the terms so that I could just focus on that part, right? Now is when we're going to deal with what is the numerical coefficient piece. Okay, so 18 choose 6. I don't know what that is. It's a large number. 18 564? Oh, yeah. 18,564. This is 2x to the 12. Okay, and then negative 1 over x squared to the 6. So I'm just choosing to kind of take a couple extra steps here. So 18,564. So 2x to the 12. 2 to the 12 is a lot. 4,096. X to the 12. And then because this is an even exponent, the 1 in the or the negative 1 in the numerator, I suppose, will become positive. And 6 times 2 is 12, so x to the 12 in the denominator as well. And this is exactly what we want to see. We want to see that x to the 12 in the numerator cancel with the x to the 12 in the denominator. Okay? So we end up with just 18,564 times 4,096. And the constant term in this case is 76,038,144. It's a very large number. Okay. Now, one thing that I just sort of want to say before we move on to the next question is that figuring out the k value, you may be able to do that in your head in certain instances. So for example, I can see that this is sort of the denominator one is going to grow at a double the rate of the numerator one. So I need, these guys add up to 18 all together, right? Because n minus k plus k is n, and n is 18. So they have to add up to 18, but this guy has to be double that. So what two numbers add to 18 where one is double the other? 12 and 6. Okay, so you could do it that way too. And what I find is, like when I was doing this one myself, I did this one that way, but the one that we're going to do next, I had to actually work it out algebraically because I couldn't do it in my head. Okay. Okay, so for example, find the numerical coefficient of the x to the 11 term of the expansion of x squared minus 1 over x to the 10. Okay, so again, we know that n is 10. In this case, x is x squared, and y is negative 1 over x. We don't know what k is going to be yet. But we know that at the end of the day, this part has to equal x to the 11. The exponent on that part just has to be x to the 11. Okay, so what I'm going to do is I'm going to take those two pieces, and again, you don't have to do this, but I choose personally when I'm just figuring out the term number to avoid all of the numerical coefficients, because all I'm caring about is how the variables are going to cancel. And in this case, I want them to simplify to make x to the 11 at the end of the day. Okay. So what I'm going to do is just work out that part off to the side. So my x, quote unquote, x is x squared. So this will be x squared. N is 10 to the 10 minus k times 1 over x to the k. That has to equal x to the 11. And for whatever k value that's true, that will help me get my term number, because the term number is k plus 1. Okay? So I'm going to start to simplify this a little bit using my exponent laws, right? So for example, this piece will become x to the 20 minus 2k, because these two guys get multiplied together. And this part will become 1 over x to the k. that has to equal x to the 11. Yes?
Is the 1 over x to the k supposed to be negative, or is it?
Okay, so if you want to do that, that's fine. But for this step, what I do personally is I just forget about all the coefficients. All I'm caring about, because this is really only the only piece that's going to just contribute to my term number and my k value, is the algebraic parts.
Do you have diploma care about that though? Because it's
I don't think so. No, I wouldn't think so. Because remember, at the end of the day, we're going to figure out what k is and then go back and actually get the entire term. Right? We could do it that way. Do you guys want to do it that way? It's not going to make a difference. I mean, if we did it that way, we would have to have some other variable here, like an a value, to take the place of the coefficient part, right? And for me, that's like extra stuff that we're going to have to kind of redo it at the end anyway, because we have to bring in the n choose k part. Yeah.
Just to make it easier, should we just always do positive when solving for k?
Yeah. So when I'm solving for k, I always just ignore the signs and the coefficients. And then I'm definitely gonna deal with them, but only after I get my k, and then I can actually figure out what the real term is. Okay? I'm just gonna close this for now because this is not, I wanna finish this before we get this visitor. Okay? All right, so let's keep going here. On the left side, these guys multiplied together will be x to the 20 minus 2k over x to the k equals x to the 11. Okay, and then again, I got to use my quotient law for exponents, subtract exponents. And I will get x to the 20 minus 2k, and then minus k equals x to the 11. Okay. Now this is good because I have a power equal to a power with the same base, and so I can now drop the bases and just set the exponents equal to one another. And when I do that, this works out to be 20 minus 3k. Can I have like 5 minutes? Or no? Okay, I'll pause my, I'm just doing a video.
Oh, hey, Rambo.
Very quick.
All right.
$10 for a selfie.
Okay, so I have power equals power. The bases are both x. So now what I can say is that the exponents are equal to one another. And on the left side, the exponent simplifies to 20 minus 3k equals, the exponent on the right side is 11. Okay, so if I subtract 20 from both sides, I get negative 3k equals negative 9. So k equals 3. Okay? So now I'm going to go up here. K is 3. Okay? And so we can find our term number. We're looking for the fourth term, in fact. So this will be T3 plus 1. And that is n choose k. So 10 choose 3 times x squared to the n minus k to the 7 times y, negative 1 over x to the k. Okay? And 10 choose 3 rather, is, I don't know, 120? Okay. 120. Now this piece is x to the 14. This guy is negative 1 over x cubed. Now this is good because we wanted the coefficient of the term with the x to the 11 in it. And x to the 14 over x cubed is x to the 11. Okay, so when this is simplified, we get negative 120 x to the 11, which means the coefficient of this term is negative 120. Okay? All right. Last question. Okay, so one term in the expansion of 2x minus m to the 7 is negative 15,120 x to the 4 y cubed. Find m. Okay, so where would you start here? Yeah, let's fill these guys out. Okay, so n is equal to 7. What's the expression for x? 2x. And y? Negative m. Okay. And k. Okay, so you do have to be a little bit careful here. It is 3 in this case, but if you had a situation like this one, where the exponents on each of the terms in the binomial are not 1, it will not be that. Okay? So one thing you could do is pay attention to the term, or the term in the binomial that you do know. Right? So we know that the first term is 2x, and the exponent on that is 4. So this is 2x to the 1, right? That piece, the 4, has to equal n minus k. And so from there you can work out that k has to be 3. Okay? So it does work in this case, but if one of these, right, let's say this was 2x squared or 2x cubed instead, then it wouldn't be as crystal clear. Yeah. So what I would do is I would just work, like, we don't have that situation, but if you're like from this part, I would just say that piece of the term would have to be 2x to the 7 minus k has to be some coefficient times x to the 4. Right? Now, because this is a 1, right, this is going to be, 2 to the 7 minus k times x to the 7 minus k has to equal x to the 4. Something times x to the 4. So I would work it out from here. 7 minus k has to equal 4. Yeah?
So could you just like not putting the 2 in at all?
Yes. Same idea. Yeah. Yeah. Okay. Okay, so k equals 3. Okay, so now what would you do? Now that we have all of this information, what would you do next? Yeah, plug it in. Get the term in terms of m, or negative m, right? So we're looking for k equals 3, so this is going to be T4. And that will be 7 choose 3 times 2x to the 7 minus 3 times negative m to the 3. Okay? And that is 7 choose 3 is 35, I think. Okay, this is 2x to the 4. So that works out to be 16x to the 4. And then this is negative m cubed. Okay, when we simplify this whole thing, 16 times 35 is 560. So we end up with negative 560 x to the 4 m cubed. Okay. So now what? Yeah.
Would we put that equal to x right here?
Yeah, exactly. We're going to take this and set it equal to this guy. And then from there, we'll be able to solve for y. Okay, so negative 560 x to the 4 m cubed has to equal, it was negative 15,120 x to the 4 y cubed. Okay, and before I can solve for m, I really want to solve for m cubed because when I get m cubed, I can take the cube root. So I'm going to divide both sides by negative. I'm just thinking, was this one negative? Yes, it was. Okay. By negative 560 x to the 4. And then on the left side, we have m cubed. And on the right side, we have 27. Okay, so if m cubed equals 27y cubed, what's m? 3y. Yeah. Okay. And that's it.